Here, on this clear site, a contemporary house will be built in a traditional manner. A landowner has chosen a building contractor to oversee all construction phases of his house. The house was designed by an architect to fit this particular terrain and to accommodate the needs and tastes of the homeowner.
We got to be sure that this line goes in right here.
The northwest corner of the house is identified on the plans. The location of this corner on the site has been carefully planned and marked with a stake. With one point established, the builder can lay out the foundation by using a transit. A transit tripod is placed directly over the stake. The instrument itself is similar to a low-powered telescope. The transit serves as a guide throughout construction. Mounted on a circular plate which is marked off in degrees, the transit is attached to the tripod. Properly adjusted, the transit will sight a straight and level line. Now, all the other corners can be located from the measurements in the architect's foundation plan.
Let's start with this wall and stake the chimney out.
Right, okay.
The end of the measuring tape is held directly below the center of the transit. The tape is then stretched along what will be the north wall. "20 feet 5 inches from the corner, the plans call for the center line of a chimney footing. In construction work, there are often different ways to accomplish the same thing. For example, a foundation could also be laid out using batter boards and mason's line. Taking the particular aspects of each site into consideration, workers select a method according to their own preference and experience.
Right there, Jack, that's good.
The transit is also used to determine elevations of the excavation.
Right, okay.
Since the transit sights a level line, any height change in the terrain can be seen by reading numbers on an elevation rod. If the same reading is obtained at two different points, then those points are level. This foundation must be at a predetermined level, as the first floor must end up even with the top of the surrounding terrain. When all the corners have been marked with stakes, they can be connected with a trail of lime. These lines roughly mark the location of the footings. The footings, or footers, are the base on which the house will rest. They are made of concrete and are designed to support and spread out the weight of the house. Where the site consists of earth, a trench must be dug to put the base of the footings below the frost line. If this were not done, the earth under the footing would freeze and expand, pushing the footing up and cracking the wall. Local building codes will state the proper footing depth. Concrete will be poured directly into the trench. The earth walls of the trench will hold the concrete while it hardens. But in other parts of the site where rock has been blasted away, forms must be built to hold the setting concrete. Earth will eventually be backfilled outside these footings, putting them well below the surface and frost line. There are many ways to build forms. Here, planks are set in place and a cross tie is nailed on top to hold them the correct distance apart. Mason's line is used as a guide to keep the footings in a straight line. A common rule is to make the footing at least as deep and twice as wide as the wall is thick. Since the only purpose of the footing forms is to hold the concrete until it hardens, The best construction method is usually the one that takes the least time and effort. Wire is wrapped around the boards to keep them from spreading apart, and steel reinforcing rods are laid in the footings to prevent cracking. With the forms secure, we're ready to pour the footings. Concrete is mixed in different proportions for different uses. The mason contractor specifies what mixture he wants when he orders the concrete truck. A standard footing mix is 1, 2, 4, meaning 1 part Portland cement, 2 parts sand, and 4 parts gravel. Water is put in at the yard, but more can be added by the driver. For maximum strength, the mix should be as stiff as possible, yet wet enough to maneuver. In places where the truck chute cannot reach, the concrete must be wheelbarrowed. It is important that concrete be dumped close to where it will be used, since too much hoeing tends to separate the gravel from the mix and weaken the concrete. The footing is leveled with a wood float which leaves the surface slightly rough. Nails driven into level marks along the inside of the form boards enable the mason to keep the top of the footing level. Poured concrete can also be used to form the walls of a foundation. This house will be built with concrete block walls. Time for a coffee break.
How about the sound of me hitting you in the back of the head with a ball? That's pretty funny, Dick.
After the concrete is hardened, the wood forms are stripped from the footings. The forms were designed to be strong, yet dismantle easily. If the wood were buried at the bottom of the wall, it would rot and attract termites and other insects. After the forms are dismantled, they can be cleaned and reused on the next job. Gravel and sand are spread between the footings. The porous fill prevents moisture from building up under the basement floor. The block work begins. The corners are always built up first. The corners were located again by using the transit and were marked with nails driven into the footings. Mortar is then laid in preparation for the block work. The mortar is a combination of masonry cement, sand, and water. It will bond the blocks to the footing and to each other. A piece of the first block is chipped away so the corner can rest directly over the nail marker. A line is run from corner to corner and is used as a guide in laying blocks. Blocks come in different lengths and widths, but the standard height is 7 5/8 inches. The mason lays a bed of mortar which will form a mortar joint 3/8 of an inch thick between the blocks. This means that the height of one block plus one mortar joint will be exactly 8 inches, a convenient measurement. The mason continually uses his level while constructing the corners. The only guide he'll need between the corners is a line. The blocks are concrete, made of Portland cement, sand, and gravel. These particular blocks weigh about 45 pounds. Grade A blocks like these are required to have a downward or compression strength of 1,000 pounds per square inch, which means that each block could support 64 tons. In the process of setting up or hardening, a chemical reaction occurs that hardens the mortar and bonds it to the block. Once the mortar has set, the block should not be moved, for that would break the bond between block and mortar. The position of the first block in each new course is alternated with the one below so that no block ever rests directly over another. This overlapping pattern adds to the foundation strength. It is very important that all corners be square, level, straight, and plumb, for it is the accuracy of the corner work that determines the accuracy of the foundation. Every corner must be continually checked as it is built up. A corner block has a flat end, so that when it is in place, it will form a clean corner. A delivery of blocks will usually include both corner blocks and stretcher blocks. The stretcher blocks have ribbed ends and are used between the corners. From time to time, blocks must be broken and cut with a mason's hammer in order to fit properly. This block is being shaped to fit into an unusual compound corner. Although this particular corner is more complicated than most, the basic techniques involved in its construction remain the same. This is a more typical corner. The white pre-installed inserts are insulation, used for walls that will be exposed to the weather. After the corners are built up, the distance is measured between them. This reveals whether part of a block is needed to make the course the right length. If it is needed, it is inserted next to one corner. On the next course, a similar piece is placed at the opposite corner, thus alternating up the wall. This way, each mason can work from his corner toward the middle and have the last block fit exactly into place. When the mortar is mixed, the consistency is controlled by the amount of water added, which depends in part on the amount of moisture already in the sand. The mortar is mixed at a ratio of 1 to 3, 1 part masonry cement, 3 parts sand. Masonry cement is specially manufactured for laying block and brick. Portland cement can also be used for making mortar by adding hydrated mason's lime to the cement-sand mixture. The lime makes the mortar tackier and easier to work with. Masons laying block must be continually supplied with mortar so that their work is not interrupted. After one course is finished, the line is moved up and the next course is begun. If the corner work is accurate, a mason can keep a wall plumb and straight with just a line to guide him. He aligns the bottom of the block with those below and the top of the block with the line. An expert mason can lay in a series of blocks very quickly with little or no adjusting. Another course finished, the line is moved up and the next course is laid. Wall reinforcing can be installed in every other or every third course. The wire grid is used in especially long or high walls to minimize cracking and to increase the lateral strength of the wall. The wider blocks used here will also make the walls better able to withstand the pressure from the backfill to be piled against the outside of the wall. The backfilling will be done only after the carpenters have secured the first floor deck to the top of the finished foundation wall. The deck prevents the top of the block walls from pushing in. Careful repetition is the key to good block work. As one wall is brought up, another begins. All the joints that will remain exposed are struck with a convex joiner. This neatens the appearance of the blockwork and strengthens the bond by compacting the mortar joints. The size and placement of the door and window openings are specified in the plans. Corner blocks are used at the openings to give a clean vertical line. Carpenters will later install wooden lintels or headers over the openings. Steel I-beams or angle irons are used if the blockwork is to continue above the doors and windows. The height of the walls is checked with the transit. Any early discrepancies must be adjusted so that the final course is level. In order to bring the blockwork to its final height, scaffolding becomes necessary. Here the masons use tall wooden horses and planks. blocks at the top of the walls are filled in with concrete, and anchor bolts are placed on both sides of all corners and at 4 to 8 foot intervals along the walls. The carpenters will attach the wood sills of the house framing to these anchor bolts. All underground plumbing waste lines must be installed before the concrete basement floor slab can be poured. Although the coordination of the plumbers' and masons' work is handled by the contractor, the mason must be aware of the plumber's needs. The lines are cast iron, resistant to corrosion and damage. The pipes are laid in trenches with a downward pitch to ensure that sewage and wastewater will flow freely out one main pipe into a septic or city sewage system. Molten lead is used in assembling the pipes.
Huh?
After the pipes are assembled, they are filled with water and checked for leaks. Fill is then placed over them, and the surface is prepared for the pouring of the floor slab. A flexible expansion joint is nailed to the block with masonry nails. Its purpose is to separate the block from the slab, allowing for individual contraction of wall and floor. The joint is nailed along a chalk line establishing the eventual level of the floor. Polyethylene is spread as a moisture barrier. Since concrete is porous, the barrier prevents ground moisture from penetrating the basement floor. A wire reinforcing mesh is rolled over the polyethylene to minimize cracking due to settlement and shrinkage. As the concrete is poured, this mesh will be lifted up into the middle of the slab for maximum strength. The mesh is cut, overlapped, and tied together to provide continuous reinforcement. The concrete truck returns. Again, the mason contractor will have specified what mix he wants for the slab, usually 1, 2, 3, as opposed to a footing mixture of 1, 2, 4. The amount of gravel is less for a slab, making it easier to get a smooth finish on the floor. Any steel lolly column should be in place before the floor is poured. The slab is poured 4 inches thick. Once the concrete is raked to roughly the right height, it is more accurately leveled with a long, straight edge in a process called screeding. A straight 2x4 or special aluminum screed is used. This process packs down the gravel, scrapes off any excess, and determines the eventual floor level. Once the concrete has been screeded, it is smoothed further with a bull float to take out any ridges or irregularities left by the screeding. After the concrete is hardened a bit, the areas around the plumbing pipes and corners can be hand floated and troweled by a mason on knee boards. Concrete cures best when it is kept moist. If it dries out too fast, it will not harden to its full strength. Concrete will appear hard in 1 day and be hard enough to build on in 3 or 4 days. It continues to cure, reaching its full working strength in about 30 days. After the concrete is hard enough to walk on, the rest of the slab is finished with a power troweling machine. One blade setting is used to float the concrete, which brings the cement-sand mixture, the cream, to the surface. The blade setting is then changed to trowel the surface to a smooth finish. The outside of the block is generally covered with 2 coats of parge. Parge, like mortar, is a cement-sand mixture. The cement in parge combines the strength of Portland cement with the tacky qualities of either lime or masonry cement. After it is partially hardened, the first coat is scratched with a scarifier, leaving a rough surface to which the second coat can make a good mechanical bond. When the scratch coat is hardened, the second coat is applied. Although this can be done the following day, the second coat for this job was not applied until all the basement windows and doors were installed by the carpenters. This way, the parge, or stucco as it is sometimes called, can be brought right up to the trim, leaving a neat finish. Parging gives a finished look to the foundation and helps waterproof it as well. Any areas that will be underground after backfilling receive additional waterproofing with an asphalt coating. The foundation of this house is now complete. Yet the foundation is only the first step towards completion of the whole house. The framing and further house construction can be seen in our next film, Carpentry, the Basic Shell.